So for this practice one, we decided if we're going from 1 to 2, we're going to keep the 0 to simplify our lives. We're going to go from 0 to 2, the big area, from 0 to 2. It's actually going to look like this. And then we're going to take this little area, and then we'll figure out what to do with that later. So there's n rectangles. Width for the 0 to 2 part is 2 minus 0 over n. And then we're going to take the width times I, 2I over n, put it in for x, and get the height. So the area is going to be the limit as n goes to infinity. And you have to write all of these steps. It's a proof. The sum I goes from 1 to n of the height times the width. 3, I think this is going to be 4I squared over, careful, n or n squared? N will ruin it for you. N squared will be great. Times the width, which was 2 over n. Yeah?
How did you, so does the height not change? Because one will be the next step, the height will be the same?
Let me simplify this one. Area equals limit n approaches infinity. Sum as I goes from 1 to n. 3 times 4 is 12. Times 2 is 24. I squared over n cubed. And we'll finish that in a little bit. Why don't you go through the motions to get to here with 0 to 1 and see how that looks. Let's check it out. So you have n rectangles, right? And then your width is going to be 1 minus 0 over n, or 1 over n. The height is f of the width times I, okay? Because the I is going to be used in the summation part. So the width is 1 over n times I is I over n. Plugging it into the formula, it'll be 3 times I over n squared. See how it's a little different than this one? It's a little different. But the area is still going to be the limit n approaches infinity. Sum I goes from 1 to n of the height, which is 3I squared over n squared times the width, 1 over n. Then this is going to be the limit as n approaches infinity. Sum I goes from 1 to n. 3I squared over n cubed. Who got 3I squared over n cubed? Nice. Nice. So now we're going to, let's go with red here. Area is going to be limit n approaches infinity. Pull out the constants. Let's use the highlighter again. Keep these I squareds alone. So you're going to get 24 over n cubed. Sum as I goes from 1 to n of I squared. This one is going to be the limit n approaches infinity. The sum I goes from 1 to n of I squared, 3 over n cubed. Okay, and then this one, we can get that from somewhere. Where do we get that? Oh, apparently not on that one. Apparently I don't have it on that slide. Okay. But I'll give it to you. And on the quiz, I'll give it to you. Don't worry about that. So then we'll use blue again. Limit as n approaches infinity of 24 over n cubed times n times 2n plus 1 times n plus 1 all over 6. Now, what will this limit be with this 24, n, 2n, n 6n cubed. That's just going to be what? 24 times 2 is 48n cubed over 6n cubed, which is what? 8. That's the area from 0 to 2. You find the area from... All right, so this one, did you get, for this one, limit n approaches infinity of 3 over n cubed times n times 2n plus 1, n plus 1 over 6. And for this guy, if you highlight those, sorry that this is so little hard to read, but it's 3n times 2n times n, and that's going to be 6n cubed over 6n cubed, which is what? 1. So the area is which? 8 or 1? It is 8 minus 1, which is 7. Now, 7, that seems a little simple, doesn't it? It seems like something is wrong here. Why does this seem so easy of an answer? 3x squared going from 1 to 2. Why does that seem weird to us? Well, it's because fundamental theorem of calculus would put what into the function here to find the y's? 3x squared. What would the width be? dx. What are the boundaries of this one? 1 to 2. So if we took fundamental theorem, what's the antiderivative of 3x squared? You're thinking derivative. It's 3x raised to the power by 1 and divide by the power going from 1 to 2. And what happens here? Cancels out. And so you're going to get 2 cubed minus 1 cubed. Which is... Okay, you know, I've never heard that before. No, I'm just kidding. But, well, the thing about the first way is you're proving this. This is hocus pocus, really, to get this answer. You know, it's amazing. It's incredible. But, I mean, do you really know what's going on? Not at all. But this one really says it all as far as what's happening.